If you subscribed, you should have gotten a notification as well. So let's move this out of the way. So yesterday was tough. It was really tough, and I think that I was very close to a solution, but yeah, I need to revisit that some other day because it was too much. I couldn't do it yesterday. I streamed for 4 hours. I got in somewhere fairly fast, but I didn't fix it in the end, right? So I think, let's see, what does it spit out? So here you can see I managed to get like I couldn't do the translation from one to another scanner, so I got all the probes and that link up, and I think because I only did one diff between them to try and find the offset and rotation, I think that one needs work, because I figured you could also be looking at it inverted, so you need more data points to know for sure. I think that's about the issue, but we're not going to do that now. We're going to do day 20 and revisit day 19 someday when we have a lot more time, which is something I don't really have right now. So yeah, let's read day 20. Okay, let's see. Day 20, trench map. With the scanners fully deployed, you turn their attention to mapping the floor of the ocean trench. When you get back the image from the scanners, it seems to be just random noise. Perhaps you can combine an image enhancement algorithm and the input image, your puzzle input, to clean it up a little. For example, okay. So that's a lot of on-off pixels. The first section is the image enhancement algorithm. It's normally given on a single line, but it has been wrapped to multiple lines in this example for legibility. Okay. The second section is the input image, a two-dimensional grid of light pixels and dark pixels. Okay. The image enhancement algorithm describes how to enhance an image by simultaneously converting all pixels in the input image into an output image. Each pixel of the output image is determined by looking at a 3x3 square of pixels centered on the corresponding input image pixel. So, to determine the value of the pixel at 5,10, okay, we don't even have that in the original image. That is very interesting. Because this was enhancement data and this was the actual image data, so we don't have a 5,10, but we'll get there, I think. In the output image, 9 pixels from the input image need to be considered. Okay, so everything except 5,10. Oh no, it also has 5,10. Okay. Oh yeah, 3x3 grid with that one in the middle. Right, got it. Sure. So it's the pixel plus all 8 neighbors, right? That is fine. These 9 input pixels are combined into a single binary number that is used as an index in the image enhancement algorithm. Okay. Okay, let's see. For example, to determine the output pixel that corresponds to the very middle of the image, the 9 pixels marked by ... would need to be considered. So this one, and this one. Okay. Starting from the top left and reading across each row, these pixels are that blah blah. Yes. Combining them to dark pixels. Yeah. The binary number is this. Yeah. Okay, that's easy. Can be formed with just 34 in decimal. The image enhancement algorithm string is exactly 512 characters long, enough to match every possible 9-bit binary number. Yeah, because 8 bits is 256. Adding 1 gets you there. So 1 bit doubles the capacity, so you get 512. Okay. The first few characters of the string, numbered starting from 0, are as follows. In the middle of the first character, 34, right, this. So the output pixel in the center of the output image should be a light pixel. This process can then be repeated to calculate every pixel of the output image. Through advances in image technology, the image being operated on here are infinite in size. Every pixel of the infinite output image needs to be calculated exactly based on the relevant pixels on the input image. The small input image you have is only a small region of the actual infinite input image. Okay, the rest of the input images consist of dark pixels. For the purpose of the example, to save space, only a portion of the infinite size input and output image will still be shown, okay? So it's, how long will the actual image be? Notepad. If I could type notepad, that would have been notepad. So this one is 16. Okay, so 16 by 16 probably. Oh yeah, that would be okay. 16 by 17 probably then. Okay. With more dark pixel extending forever in every direction, not shown here. By applying the image enhancement algorithm to every pixel simultaneously, the following output image can be obtained. Through further advances in imaging technology, the above output image can also be used as an input image. This allows it to be enhanced a second time. Okay. Now the smallest details are really starting to come through. After enhancing the original input image twice, 35 pixels are lit. Start with the original input image and apply the image enhancement algorithm twice, being careful to account for the infinite size of images. How many pixels are lit in the resulting image? Okay. That's interesting. Ah, that's a big one. Okay. Crikey. Okay. So yeah, let's start with the test input here. It's a fun one with a bit of binary and all sorts of stuff. Let's see, day 20. And I need to open this to make sure I see chat. Okay, extension. No, not extension, program. And then we go to day 20. Boom. Okay. Hey Simon, welcome. And look, it's good. It's a good thing that I opened it on another screen because, as always, my YouTube studio, if you look here, it's not even expanding. Wait, what? Let's see if this works better. A pop out of the chat works better. Okay. Should probably do something to make this topmost or something. But yeah, okay. I got chat. Woohoo! Let's see. Because YouTube Studio is always a pain in the ass. But yeah, let's see. Const string test input is not that. So Simon, did you do day 19 yesterday? Did you finish it? And did you see me struggle for 4 hours? No. Okay, that's a test input. Test input dot split by. Actually, I can do it 2 lines. And then we can do var L. Also is, yes, but the runtime is a bit long. Okay. Yeah, I still need to go back. I think I found a very cool way to identify everything, and it's like near instant, but I still need to do a few more processing to figure it all out. It was a really fun one, but I didn't. It was so late and I was so tired. I was just chasing the same thing over and over again. When I solved it, it was 2 minutes 30 seconds, but I got it down to 20 seconds. Okay. I still think that if my code works, it could be like 10-15 milliseconds or something. So, but maybe I'm wrong. Boom, 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 boom. Let's do this first. Algorithm. I probably need to reduce my bitrate here. It's already at 1440p and buffering. So is your thing buffering there? Runtime for second challenge was 0.5 seconds. Okay. Okay. Yeah, but that was like Manhattan distance thing. That should be very easy once you solve part 1 in the correct way. So we do lines first dot select x dot select no to char array. And this one, x is already char. Okay, we do x. Okay, let's see. Const char true. I can do on is this. Const char off is dot. Const char fill is, and I like this one. I did it for another challenge. Is alt 2119, I think. Yeah. So I prefer to use this one when printing. It makes it much easier to read. Dun, 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 dun. Why is it complaining here? Ah, there's an accent in the C. Okay, so here we do C equals to on to array. Okay, so now we have an array of bools, which is fine. Dun, 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 dun. Yeah, I'm okay with that. I still need to figure out, by the way, the so if you do the first pixel, there will be no neighbors. So if you just do it simpler like that. Oh no, they said it would be like an infinite image, so you can just treat everything out of range as 0. Bum, 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 bum. Okay, so now we need to do a dictionary int x, int y, comma, actually we can just use a hash map or a list. Pixels is new blah. We can do for map is for image is lines.skip1 to array. For int row is 0, row smaller than image that count, a length row. Boom, 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 boom. And call is image 0.length. For int call is 0, goal smaller than goals. Boom. I could have called this x and y as well, but yeah. So now we do pixels. Actually, if image. So this will be a string. I can do a char array, char row data. So we do row data is image row, and actually you can already access this as an as a char array, but let's just do it like this. It's fine. If row data call equals on pixels that add this is col, comma, row. Boom. So now we have a sparse map of all the images, the pixels that are on. Boom, 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 boom. So maybe we should do a print function that just takes the min and max and just prints it out. But now let's see. We need to have a bool get pixel int x int y. Let's see. We need to have all the pixels and we need to have the algorithm. So bool I probably need to make a function to get the index out of the. Now let's do that first. Let's see. So we can do list. I'm inside the sample text. Let's not do that. List int x int y neighbors. I should make a function from this already, but it's okay. -1 -1. Come on. Let's see. We have -1. We have 0. We have 1. Then we go to the 0 parts. 0. Then we have the +1. So -1, +1, -1, 0, 1. So these are all the 8 squares around it. I use a dictionary of location x, y and parse everything to booleans. Yeah, I'm doing just about the same. Boom, 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 boom. And I need to do this in reverse. So let's first get index. Let's first do that. It's basically the same, but I think I need to split it out still. So that's the one without the algorithm here. We don't care about that one yet. So we do int index is 0, and we do this one in reverse actually. That's annoying. But okay, let's just do should probably just have something for that, but in this case we just need to walk these, and we also need to do the same. Let's just do like 0,0 here to make sure that we can just walk this list and get all the values. Okay, so we do for int I is 0, I is smaller. Here's that count plus I. So this one will take care of the bit shifting stuff. So we do int x int y target. Target is x plus let's see, offset. Offset is neighbors I. Offset.x, comma offset.x, y plus offset.y. So if pixels at try get value, come on, try get value, target, out, bool. Actually, what's in there? Actually, I just need to do it contains. Actually, contains that, and then we do index plus equals 1 shifted to I. Console, come on, return index. So let's see. Does it actually need? It doesn't need the algo here. Yeah, it needs. So return algo index. So this actually becomes just this, and it can be an arrow function. Okay. And I can do the same for set pixel. But do we want that? No, that's not. Dun, 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 dun. So we have something to get what the pixel should be. We can get index. I'm just thinking when I do this, because there's something I'm forgetting here. We only have these pixels set. So whenever there's a pixel set, that means there's a 3x3 square that this one hits that needs to be calculated. Because for every pixel in here, we need to make sure that we that means that it's part of a 3x3 square that will actually produce output. Ooh, and I wonder if like the input is a 0 for the an active one for the first one, that means that all zeros turn on. Yeah, like here. So if your number is 0, that means you flip everything on infinitely. So, okay. So if it's infinite, then okay, let me just read it again. Well, basically I can probably, it's infinitely expanding, so I can treat it as if there's nothing above and to the left of this, right? So that makes sure there are no zeros there, but to me this is weird, because if the first one in here is a on, that means that everything that has no pixels will return 0, which means that it flips on. So that's just weird for me. Oh, but that's why you do two of them. So the next one it would turn off. Is that true though? Because I assume the test input, yeah, see the test input has the first one off. So I really wonder. Okay. I probably just need to make sure that I do this one first. Infinite in size, every pixel infinite output needs to be calculated exactly based on the relevant pixels. Okay, small input image you have is only small region of the axle, blah blah blah. Disabled space in every direction, okay. Sure. By applying the infinite maybe I'm reading too much into this, but yeah, let's see. But my thinking is that so I need to make sure that I take like for every pixel that hits, I need to do a way bigger square around it, because it's all part of an image then. Let's see. So what would happen here? Right, because let me just check the input again. Like here. So that means that this pixel gets turned on because there is something here, probably. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Jesus, what's that? Somebody's spamming my Telegram. Okay, sorry for that. So I just think I need to do this, but that means if I hit a pixel here, I need to start from here to calculate all. So there's like a, you have to cover a bigger square. So let me see. Void pro. Let me see. For int I is 0, I smaller. 2 increment I for each, and I need to keep track hash set int x int y. So here I can do process.clear clone is no, let's see. Do I even save this? Oh yeah, the pixels. Okay, so pixels to array. That's fine. So now we do for each var pixel in clone. And then we do a -2 to +2. So we do for int y is pixel dot y -2 y smaller than pixel dot y +2 increment y. Check the last bit. Okay, I'll read that later. Let me just fail first. But it's good to know that somebody's watching that can help if I stumble too hard. So we do if, so we can do the same here that I did before. Int x, int y, target. Target is x, y. If process, contains target. Continue. You don't want to process stuff twice. Let's see, and then we do pixels dot. Let's first do because this get pixel I need to do okay. Cool. Let's see. Okay. Pixel val equals get pixel. This will be clone. We go target.x, target.y. So let's just rewrite this to take in this as a single variable. Target. Okay. Get index. Okay, this needs to be optimized indeed. So we do here is a new hash set. Come on. Boom. Okay. Then we do process.add target. If pixel val, we do pixels.add if not pixels that contains target, pixels.add target. Else if pixels that contains target, pixels that remove target. Okay, so this toggles the images. So I should probably write out like the condensed image right now. Min x, max x, and min y, and max y, get bounds. Boom. Y is max value, max x is max I is 0. Let's see. Issue. Okay, max x, max y. Okay. For each var pixel and pixels. If pixel dot x smaller than min x is pixel x. If pixel dot x larger than max x, x. If pixel y smaller than min y is pixel y. If pixel dot y larger than max y is pixel dot y. Okay. return, and then we get min x, come on, min x, max x, min y, max y. Okay. So now we do void print. Okay. Why doesn't it like this? Right, we need to do the same for y, and we need to do, okay, let's not compile now. Okay, and in this case we need to have this be a hash set to make this fast. Console.write. It's always the one case you don't want write line, you get that. So we do pixels.contains x, y, build. Let's call this one empty. Okay. Const empty is, and that will be just a space. Okay. So let's do this right now. I want to print pixels. And we do the same after each loop here. So let's see what happens if we do this. Oh, what's the exception? I got an error, but day 0, I didn't update the base file. Okay. Okay, let's see. I should probably add an extra new line. Let's just add that to print as well, to just like give a space before and a space after. That should make it clearer. So is this what we see here? And I think it is. Cool. Yeah, I think that's it. Okay, so let's try the real input. What was actually the question? I think it's just the pixels.count, right? Let's not start with bucket or hit up here. Let's see. Console.writeLine day part 1. Pixels.count. Come on, why is my IntelliSense not working? Lowercase pixels, okay, my bad. So that should spit out 35, and that is correct. Okay, let's do the thing on the real input. Input 2 lines. Boom. That's not the right answer. Your answer is too high. If you're stuck, make sure you're using the full input data. Oh no. Okay. So let me see. This is where it gets interesting. It would if I actually had a clue what I'm doing wrong. The thing is, it works with the test. You didn't think it would be that easy for day 20, did you? Well, yeah, actually I thought it would. So the only thing I can think about is that what I said at the start is that it starts with infinite ones, because everything that's 0 will get turned on, but I can't draw infinite ones. So yeah, I have no clue what I need to do now. Because, like, what I imagine is that everything past here, everything past the original image will be 1. So, it will be 0, so it will turn on. And that means that... No, I don't know. I really have no clue what they want to do. Let's see. Put the scanners. Let me see. This process can then be repeated to calculate. Because the thing is, and I can already show you, if I do like get pixel like this. This will be true because there's no data, so it will return a 0, and then let's see, get pixel. Yeah, okay. Pixels, I'll go. Come on. So if I return this will return true, right? Because everything that's black will return 2. So what I don't understand is what would happen if that gets triggered again. So like I can consider everything to be oh wait, I can actually. So based on the first pixel I need to track either the lit or the unlit pixels and then do the inverse. Yeah. The only thing is I have no clue how this algorithm will flip an infinite value. Oh, because the last one, yeah, okay. The last bit of the algorithm is false, so that means that after, yeah, I can simulate this actually. So I actually don't need to calculate all of this. Oh, but it has an impact, right? Yeah, I know. Check the last bit. I mean, it's 0. So that means that it gets turned off if everything is set. But that also has an impact on everything around it the first time. So the second to one, like the previous one, also turns off the entire edge. So I could probably just count all the ones that are in the edge values of the pixel right now, of the image. So if I think I can actually cheat this. So let me see. Because if what I'm thinking is correct, reading the algorithm here, that means like after the sea of ones, these turn off again. So everything that's on flips back after the second time, but the one before that also. So that means that the outermost edge gets turned off. Then one gets on, and then 2 more gets turned off. Oh no, wait, it's only 1 in the direction there. So I think if I just ignore everything that hits one of the bounds, I'm actually correct. So let's see if my hypothesis there is correct. Otherwise I just need to rewrite this whole thing. So let's see. Var bound is get bounds pixels. And then we do pixels dot where x dot let's just call it p for once. P dot x is bounds dot min min x, or p dot x is bounds dot max x, or p dot y is bounds dot min y, or p dot y is bounds dot max y, to list, and then we can do pixels dot accept. Is it accept with? Removes elephant, Let's see if I can get cheeky and get away with this. Probably not, but it's worth a shot. Still too high. Okay, so more gets flipped. Okay. Okay, so let's not do this. This never happened. And let's just copy this into part 2. And actually do the inverse here. I'm just not sure. Pom, 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 pom. Actually, we need to simulate it once. No, I don't need a hint. We need to simulate it once, and after that, you can you switch from storing the set bits to the unset bits, and you use that. So let me see. So part 2 actually is this. Pixels. So we do this. We don't need to print this. We don't need to print that either. Pum, 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 pum. Let's see. So after we do this once, then we do var. Let me see. Because my reasoning is that we now need to track the dark pixels, because let me see. Because everything that's off, that is out of bounds, will always be let me see. Yeah, I think we just need to do the inverse here. Let me see. It's not, no, we do that. No, but the first time, let me think. Let me see. Since these are all set, that means that everything just out of the border will get set to on after the first step. So I can assume that after the first step everything is on, and we just need to track the off pixels. Boom, boom, boom. So everything inside of the bounds needs to be off. Let me see. Pixels. Dark pixels. Boom. Let's do this. Else dark pixels. Add. Cold row. I should actually probably just keep the state on off and have one array, and that means just everything that we touch, and we can assume the rest is actually on until it flips. Right. I'm having a tough time reasoning about it because it just needs so much. Let me think. So we have pixel val there. Let's just make this a dictionary bool. But the default state will now become that if it's not in here, that it returns off for the first time, but after the first loop it will be on. Man, to dictionary. So this will just clone that whole thing. So we also need to change this one. Let's see. Get index. Default. Oh, I need to call that default on actually. Okay. So this can still remain an arrow function like this actually. Boom, 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 boom. Man. Let's see. Try get value. Targets out. Bum, 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 bum. What does it return? Yeah, okay. I need to change it into a version that takes in the dictionary as well. And then we get try get value out bool on. Yeah, this is annoying because you only want to, if this one is found, then you need to make sure that you adhere to this value. So I probably need to make this into an else if. Let's see. If this, else. Default on. So easy. So here we do if on. Now we do this. Because if it's not on in the dictionary, we don't want to add that value. So that is that. Let's see, part 2. Okay, so that also, let me see, get pixel. Oh yeah, I need to give a default value there as well. So the first time this will be false, and the second time it will be true. Let's see. Contains key. And then we need to have pixel val, which can be on or off. So we always do this, and else we update the value. You can probably do that because you could always just override it based on that index, but yeah, that is fine. Now I just need to know how to account for that outer border. Let me just see what I get when I do this for now. So the second time I need to do this like this. And then we have true. Okay, that's not good because the value has gotten a lot bigger. Let me see. I need to turn off printing for part 1. That's for sure. So this last part is interesting, but trying to figure out. Because looking at this would tell me that it would close off the border, but kind of wondering what would happen if I would run this just on a blank number just to see what would happen. So let's see. Let's just say for y is 0, y is smaller than 10. Let's just be in a blank space for now. Okay, I need to actually, I can just do pixels.clear here. I could have done that right away. I can just clear the pixels and just do 0 to 10 and just see what happens. I can do 30, whatever. 0, 30. Come on. Build arrows, okay. Okay, what's another error? Okay. We have the same issue there. I can just put in keys there, that's fine. Let me see. Keys. So that is fine. Contains key. Actually, I can do try to get value out bool light up. Okay. turn. Okay. So that is what we expected, but we need to do that twice. Okay. Okay. So for that entire field, it clears that and then leaves you with a single line. Like this corner out of it. I just wonder if I just should just expand one row or something. Because if this is the infinite field, how long does this stretch? Yeah, I'm not so sure. Luke, you can give me a hint, because I think I'm chasing my own tail here. And actually, this is still part 1, so I haven't even solved that yet. And I put it in part 2. That line figure that happened was interesting. I wonder why that happened. I thought it would have been blank. But the top row... wait. I'm an idiot. Let's run this again. Okay. So the second time it's fully negated. That's what I expected there. Okay, let me see. Process. Blah, blah, blah. So if I stop to do this, and also need to not print pixels that count. It actually goes up to like 100k here. Amazing. Where x value. Is this the answer? Phew, answer's too low. Okay. Let me see. Oh, I actually didn't do this part. Okay, let me just stop being an idiot here. If I can do that for a bit. Okay. I already had this one. So let me see, notepad. I had too low. Okay, I can't even see my other input, so I'm not sure if I should try this one or if that's something that I've inputted before. Because I think I had like 5.4 or something before and that was too high. Yeah, I really wonder how to treat the infinite, because from my experiment here, like, oh wait, did I mess with that here? Dun, dun, dun. It took me 3 attempts before I realized what was going on. Yeah, well, my test showed me that, let me see, that was this one here. Can do for in I is 0, I smaller than 2, plus I. I still need to clear the pixels, right? So if everything outside of bounds, what happens is that you first get a filled square and then you get a blank square because it cancels it out the second time it runs. So everything that's out of bounds will flicker on and off. The thing is, I probably don't simulate how the edge case is handled properly, which just drives me crazy. But yeah. Oh wait, what? I had that whole thing in there twice. Pixels not clear needs to be removed. For my algorithm, that information just meant a 2-line change for me. Yeah, but I really don't see it and I think I'm gonna stop because it's taken me too long already. Just getting frustrated by this point because I'm just going back and forth and yeah. I was already tired when I started this and I don't really feel like going on for a long time trying to figure out the last part that I'm missing here because I feel like I understand what's happening and what I should do. It's just the solution doesn't come to me because from this you can see that it just blanks out everything that's like filled with like this toggles on and off the white space because this one says that if you're in no man's land, it will turn on. So the first and the last parts dictate how that is treated, and I just think it probably does something with the edge. I just don't know. It'll be obvious when you come back to it. You just need a break. Yeah, but I felt the same about yesterday's problem. I kind of like this challenge because it once again gave me something to bit shift, and yeah, it's just very frustrating when the test case it works and then the input has like a wrench thrown at it, because this is like I expected this maybe for the part 2, right? But now I feel like, hey, I've implemented all their logic except for one tricky thing, and I got the test input to work, and then yeah, the input is tricky to make sure that this doesn't even work. So that's a bit annoying. Yeah, the first thing that I thought after I saw it was like, okay, instead of the lit pixels, I now need to keep track of the dark pixels. But those are also, like in the first case, they are infinite, because everything is dark. But basically everything that's not affected switches from on to off every time. But there is an edge case. Like these edge values. So like here 3 are on. Because inside of here it's all fine. It's just like, how do you treat the edge case? So that, because that basically means, because the edges are all 0, that means any value means it gets turned on, right? So the entire edge is lit up here, because it doesn't matter which value is in there. The trick then becomes, what happens, because it needs to have 0, 1, 2, 3, it needs a value of 4, 6, 8 or 9 to turn off, and all others get turned on. No, that's not true. There's much more in range, because it's bit shifted. Oh man. Wait. I'm reading this wrong. Yeah, because these 3 values, 1, 2, it's 1, 2, 4. Yeah, it's bit shifting. Just thinking like, if you take this as the bottom right part, so above and to the left, those are all zeros. So then this one is a 1. If you look at this part with the space, and this one is 2. If you look at like this, it's a 4. So all of this still gets turned on here. The question is what happens when you get to these regions. But yeah, now I'm gonna call it a day because I'm not getting anywhere. I'm just a bit tired right now. Gonna go home, get some sleep, and return fresh tomorrow. So yeah, I want to thank you for watching me struggle for a whole hour and a half. So I was so happy when this actually worked fairly fast with what I thought. Just like the wrench in the end. That yeah, it's a bit frustrating to not get it, especially after yesterday. So yeah, let me just kill this as well. Don't need that. That was for day 19 as well. So yeah, I'm going to end it here and maybe come back tomorrow. So thank you for keeping me company, and I'll see you guys tomorrow. Bye bye.